Dear students, ਤੁਸੀਂ ਹੁਣ ਤੋਂ ਪਹਿਲਾਂ ਵੀ ਇਲੈਕਟ੍ਰੋਨਿਕਸ ਨਾਲ ਹੀ ਰਿਲੇਟਡ ਕਈ ਟੌਪਿਕਸ ਤੇ ਇਹੋ ਜਿਹੀਆਂ ਆਡੀਓ ਵਿਜ਼ੂਅਲ ਕਲਾਸਿਸ ਅਟੈਂਡ ਕਰ ਚੁੱਕੇ ਹੋ। दरअसल इलैक्ट्रॉनिक्स प्रैक्टिकल ओरिएंटेड सब्जेक्ट है। इस बारे सिर्फ थियोरेटिकल जानकारी होना काफ़ी नहीं है। जे इलैक्ट्रॉनिक्स ते प्रैक्टिकल यूज़ की गल करिए तो साडा भाव है अणगिणत गिनती विच इलैक्ट्रॉनिक गैजेट्स ते सर्किट बनाउण विच इस ते इनवॉल्वमेंट दी। इलैक्ट्रॉनिक गैजेट्स जिमें कि ट्रांजिस्टर रेडियोस, ट्रांसफॉर्मर्स, रोबोट्स, एम्पलीफायर्स, सैटेलाइट्स आदि। You know very well that all these devices are always designed to work with a prefixed efficiency. How do you think the efficiencies of electronic gadgets can be fixed? This is done by calculating the specific values of the electronic components to be used in these circuits. So, could you guess what are we expected to learn in today's class? Precisely yes, we are to practice some numerical problems on semiconductors today, which are utmost important from practical point of view. You are all welcome to this class of equations, formulae and problems. One of the most common important electronic component is a transistor. So, we start with reminding ourselves with some important formulae related to transistors and then work out a few numerical problems related to these. Let us start with transistors as amplifiers. For transistors as amplifiers, if IE, IB and IC be its emitter current, base current and collector current respectively, then according to Kirchhoff's law, IE is equal to IB plus IC. Then the AC input resistance of the transistor in common emitter configuration is defined as the ratio of small change in base voltage to the small change produced in the base current at constant collector voltage and is denoted by Rin. If delta VBE is a small change in base voltage and delta IB small change produced in base current at constant collector voltage VCE, then Rin is equal to delta VBE upon delta IB at constant collector voltage VCE. Similarly, the AC output resistance of the transistor in common emitter configuration is defined as the ratio of small change in collector voltage to the small change produced in collector current at constant base current. It is denoted by Rout. Thus, Rout is equal to delta VCE by delta IC at constant base current. AC current gain is defined as the ratio of change in collector current to the change in base current at constant collector voltage. It is also called current transfer ratio and is denoted by beta. Therefore, beta is equal to delta IC by delta IB at constant VCE. AC current gain is defined as the ratio of change in collector current to the change in emitter current at constant collector voltage. It is denoted by alpha AC. Alpha AC is equal to delta IC by delta IE at constant VCB. Let me now remind you of transconductance, AC voltage gain and AC power gain also. Transconductance is defined as the ratio of change in collector current to the change in base voltage at constant collector voltage. It is represented by Gm. Therefore, Gm is equal to delta IC upon delta VBE at constant collector voltage. ਇਸੇ ਨੂੰ ਇੱਕ ਹੋਰ ਢੰਗ ਨਾਲ ਵੀ ਲਿਖਿਆ ਜਾ ਸਕਦਾ ਹੈ। Gm is equal to delta IC upon delta VBE into delta IB upon delta IB, which gives delta IC upon delta IB into delta IB upon delta VBE, or Gm is equal to beta AC into 1 upon Rin. ਹੁਣ ਬਾਰੀ ਹੈ AC voltage gain ਦੀ, which is represented by AV. It is defined as the ratio of the change in output voltage to the change in input voltage. If on applying an AC input signal, the input current varies by delta IB and correspondingly the output current varies by delta IC, then AV is equal to the change in output voltage to the change in input voltage, or AV is equal to delta IC into Rout upon delta IB into Rin, which is also equal to delta IC upon delta IB into Rout upon Rin. This gives us AV equal to beta AC into resistance gain. ਅਸੀਂ ਜਾਣਦੇ ਹਾਂ ਕਿ beta AC is always greater than alpha AC. AC voltage gain in common emitter amplifier is quite larger than as compared to that in a common base amplifier. ਇਸ ਲਈ ਇਹ conclude ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ ਕਿ AV is equal to Gm into Rout. Let us now learn about the AC power gain, which is defined as the ratio of the change in output power to the change in input power, or AC power gain is equal to delta IC square into Rout upon delta IB square into Rin, which simply implies AC power gain as equal to beta AC square into resistance gain. Since you know that beta AC square is always greater than alpha AC square, AC power gain in common emitter amplifier is very large than as compared to that in common base amplifier. ਆਓ ਹੁਣ ਇਹਨਾਂ equations ਅਤੇ ਫਾਰਮੂਲਿਆਂ ਦੀ ਵਰਤੋਂ problem solving ਲਈ ਵੀ ਸਿੱਖ ਲਈਏ. The input resistance of a silicon transistor is 500 ohm. Its base current is changed by 25 microampere, which results in the change in collector current by 2 milliampere. This transistor is used as a common emitter amplifier with a load resistance of 6 kilo ohm. Calculate A. the current gain beta AC, B. the transconductance Gm, and C. the voltage gain AV of the amplifier. For the solution, according to the question, IB is equal to 25 microampere or 25 into 10 raised to the power minus 6 ampere. Collector current IC is equal to 1 milliampere or 1 into 10 raised to the power minus 3 ampere. Rn is equal to 500 ohm and RL is equal to 6 kilo ohm or 6 into 10 raised to the power 3 ohms. Now, for finding the current gain, beta AC is equal to delta IC upon delta IB. Substituting the values of delta IB and delta IC in this equation, we can write beta AC equal to 1 into 10 raised to the power minus 3 upon 25 into 10 raised to the power minus 6, which is equal to 0.04 into 10 raised to the power 3 or equal to 40. Transconductance Gm is equal to beta AC upon Rn. Substituting the values of beta AC and Rn in this equation, we can write Gm is equal to 40 upon 500 ohm or equal to 0.08 ohm inverse. For finding the voltage gain AV, we know that AV is equal to Gm into RL. Substituting the values of Gm and RL in the formula, we get AV equal to 0.08 into 6 into 10 raised to the power 3, which turns out to be 480. In our next problem, the base current of a silicon transistor is 80 microampere and its collector current is 1.80 milliampere. Find the values of beta, IE and alpha. Also, calculate the value of beta if a deviation of 18 microampere in its base current causes a difference of 0.55 milliampere in the collector current. Now, let us find the solution. Given here is IB is equal to 80 microampere or 8 into 10 raised to the power minus 5 ampere. Collector current IC is equal to 1.80 milliampere or 1.80 into 10 raised to the power minus 3 ampere. Now, we know that beta AC is equal to delta IC upon delta IB. Substituting the values of delta IB and delta IC in this equation, we get beta AC is equal to 1.80 into 10 raised to the power minus 3 upon 80 into 10 raised to the power minus 6 equal to 0.0225 into 10 raised to the power 3 or equal to 22.5. Next, we calculate the value of IE, its emitter current, which is, of course, equal to the sum of the base current and the collector current. That is, IE is equal to IB plus IC. Adding the values of IB and IC, we have IE equal to 8 into 10 raised to the power minus 5 plus 1.80 into 10 raised to the power minus 3. That is 0.00188 ampere or 1.88 into 10 raised to the power minus 3 ampere. Then we also need to calculate the value of alpha, which is the ratio of IC and IE. So, dividing the value of IC by that of IE, we have alpha as equal to 0.957. Finally, let's calculate beta AC for fluctuations in base current and collector current. Knowing that delta IC is equal to 0.55 milliampere, which is equal to 0.55 into 10 raised to the power minus 3 ampere, and delta IB equal to 18 into 10 raised to the power minus 6 ampere. Also, that beta AC is equal to delta IC upon delta IB. We substitute their values and divide them. This gives beta AC equal to 0.55 into 10 raised to the power minus 3 upon 18 into 10 raised to the power minus 6. On dividing, this gives beta AC equal to 30.55. And now, can you recall that the relation between the current gain alpha and current gain beta of a transistor? Well, this relation is beta is equal to alpha upon 1 minus alpha. Let us use this equation also to solve some questions. A change of 8.65 milliampere in the emitter current of a transistor causes a change of 8.6 milliampere in its collector current. Calculate what change in the base current is necessary to produce an equivalent change in the collector current. To find the solution, delta IE is equal to 8.65 milliampere or 8.65 into 10 raised to the power minus 3 ampere. Similarly, delta IC is equal to 8.6 milliampere or 8.6 into 10 raised to the power minus 3 ampere. We know that alpha AC is equal to delta IC upon delta IE, that is 8.6 into 10 raised to the power minus 3 upon 8.65 into 10 raised to the power minus 3, which is 0.9942. Since we have beta AC equal to alpha AC upon 1 minus alpha AC, we substitute the value of alpha AC and get beta AC equal to 0.9942 upon 1 minus 0.9942. On calculating, this gives beta AC as equal to 172. And now, to find out the change in base current, delta IB, we use the formula beta AC is equal to delta IC upon delta IB, or delta IB is equal to delta IC upon beta AC. Since delta IC is equal to 8.6 milliampere or 8.6 into 10 raised to the power minus 3 ampere, and beta AC is equal to 171.4. We have delta IB equal to 8.6 into 10 raised to the power minus 3 upon 171.4, or delta IB is equal to 50.17 into 10 raised to the power minus 6 ampere or 50.17 microampere. In our next problem of today, a transistor is used in a common emitter mode in an amplifier circuit. When a signal of 12 millivolt is added to the base emitter circuit, the base current changes by 16 microampere and the collector current by 1.8 milliampere. The load resistance is 2.4 kilo ohm. Find A. The current gain beta, B. The input resistance RBE, C. The transconductance GM, and D. The voltage gain AV. To get the solution, we have, according to the given question, delta VBE is equal to 12 millivolt or 12 into 10 raised to the power minus 3 volt. Delta IB is equal to 16 microampere or equal to 16 into 10 raised to the power minus 6 ampere. Also, delta IC is equal to 1.8 milliampere or equal to 1.8 into 10 raised to the power minus 3 ampere. Now, to calculate the current gain, we have beta equal to delta IC upon delta IB equal to 1.8 into 10 raised to the power minus 3 upon 16 into 10 raised to the power minus 6, which turns out to be equal to 112.5. May we now try to find out the input resistance RBE, which is given by the formula RBE equal to delta VBE upon delta IB. Substituting the values of delta VBE and delta IB in this equation, we get RBE equal to 12 into 10 raised to the power minus 3 upon 16 into 10 raised to the power minus 6. That is equal to 750 ohm. Let us now get on to calculate the transconductance of the given transistor. The formula to be used is GM equal to delta IC upon delta VBE. On putting the corresponding values of delta IC and delta VBE in this equation, we get transconductance GM is equal to 1.8 into 10 raised to the power minus 3 upon 12 into 10 raised to the power minus 3, which gives the required value as 0.15 ohm inverse. Finally, we work to find out the voltage gain AV, which will need to use the equation AV equal to RL into delta IC upon delta VBE. Substituting the corresponding values in the given equation, we get 2.4 into 10 raised to the power 3 into 1.8 into 10 raised to the power minus 3 upon 12 into 10 raised to the power minus 3, which gives the desired value of voltage gain as 360. आओ एक और प्रॉब्लम सॉल्व करके देखिए. For a common emitter amplifier, current gain is 80. If the emitter current is 7.8 milliampere, calculate the collector and base current. Also, calculate current gain when transistor is working as common base amplifier. Now, look at the solution also. Here, beta is equal to 80 and IE is equal to 7.8 milliampere or 7.8 into 10 raised to the power minus 3 ampere. To find out the values of collector and base current, we use the formula beta equal to IC upon IB, or IC is equal to beta into IB. That is, IC is equal to 80 into IB. Also, IE is equal to IC plus IB. Substituting the corresponding values of IE and IC in terms of IB, we can write 7.8 is equal to 80 into IB plus IB, or 81 into IB is equal to 7.8. This gives IB is equal to 7.8 upon 81. That is equal to 0.096 milliampere. Again, IC is equal to 80 into IB, which is also equal to 80 into 0.096. On multiplying, we get IC equal to 7.68 milliampere. Now we have to find out the value of alpha. We will use the relation between alpha and beta to do this. That is, beta is equal to alpha upon 1 minus alpha. Putting the value of beta in this equation gives us 80 is equal to alpha upon 1 minus alpha. Solving this for alpha, we get alpha is equal to 80 upon 81, that is equal to 0.988. We will solve one more numerical problem here. The current gain of a transistor in a common base circuit is 0.95. Find the voltage gain and power gain if the load resistance of output circuit is 400 kilo ohm and input resistance is 200 ohm. Given here is R out equal to 400 kilo ohm, that is 400 into 10 raised to the power 3 ohm. Also, R in is equal to 200 ohm. The current gain of the transistor beta is 0.95. We know that the resistance gain is given as the ratio of R out to R in. Putting the values of R out and R in this relation, we write resistance gain is equal to 400 into 10 raised to the power 3 upon 200 ohm, that is 2 into 10 raised to the power 3. Since the voltage gain is equal to the product of current gain and resistance gain, we have voltage gain is equal to 0.95 into 2 into 10 raised to the power 3, which on multiplying turns out to be 1900. And now for finding out the power gain, we have the power gain as equal to beta AC square into resistance gain. Putting in the corresponding values of current gain beta and resistance gain, we get the power gain as equal to 0.95 square into 2 into 10 raised to the power 3, which on squaring and multiplying becomes 1805. And now I believe you all must be ready to answer some of my questions. My first question is, what is the relation between the current gain alpha and current gain beta for a transistor? The required relation is beta is equal to alpha upon 1 minus alpha. The next question is, express AC power in terms of resistance gain. The answer is AC power gain is equal to beta AC square into resistance gain. विद्यार्थियों, ਹੁਣ ਅੱਜ ਅਸੀਂ ਤੁਹਾਡੇ ਕੋਲੋਂ ਇਜਾਜ਼ਤ ਲੈਂਦੇ ਹਾਂ। ਪਾਠ ਤੇ ਧਿਆਨ ਦੇਣ ਲਈ ਸਾਰਿਆਂ ਦਾ ਧੰਨਵਾਦ। ਅਗਲੇ ਪਾਠ ਵਿੱਚ ਕੁਝ ਹੋਰ ਨਵਾਂ ਪੜਾਂਗੇ। ਤਦ ਤੱਕ ਗੁੱਡ ਬਾਏ ਐਂਡ ਆਲ ਦ ਬੈਸਟ।